Hi, welcome to our first video after the remote instruction startup for UCF. Alright, so what we're going to talk about tonight is string manipulation in R. This is a critical component of text analytics. So what we're going to remember that we're going to take some politician tweets and we're going to analyze them. I feel like this is a good place to start when it comes to learning text analytics. Now, I do this all the time, specifically string manipulation. This is a critical part of my job because the same data will be recorded in different manners by different people. People use abbreviations, people skip words, some people spell it out, and I need to be able to put them in a common format. Also, I need to reduce text for things like visualizations to shorter formats so that things will fit nicely onto the page. So this is an important skill set for anyone working in analytics. Now, I'm going to be doing everything in R. SAS has excellent string manipulation features, but unfortunately, SAS does not support the text analytics that we're going to be doing in a little bit. SAS Enterprise Minor does, but that stuff really, Enterprise Minor just does everything for you, so there's not really a whole lot to teach. So I'm just going to be digging into R. Everything from this evening you can pretty much do in SAS, but I feel like R definitely supports a wider range of things to do. So basically, string manipulation is a process of changing character strings into different formats. So let's think about that. Let's think about different ways that you can put down my name. You could have Aaron Smith, first name first, last name last, and then we can have Smith Aaron, last name first, first name last, and then A. Smith. That's how my dry cleaner puts it. All these are referring to the same person, but they're in different formats. And if I want to match up different data sources that have my name in different formats, I need to do string manipulation to be able to match things up. So now another thing to think about, let's think about the words jump in all caps, jumping, jumped, jumper. Well, these all really are just relating to the same word jump. So if I was doing text analytics and I see all these different words coming up, I would want to convert them all to the word jump. Otherwise, we're going to have some problems with sparse words. All right, so here is kind of a guide of how to go through and do pre-processing for text analytics. So my opinion is that you should really start out by removing URLs that are in there, remove your contractions, remove your special characters, remove punctuations, numbers, redundant, unnecessary white space, remove symbols such as dollar signs, convert everything to lowercase so that it's uniform throughout, remove stop words. Stop words are words that are not informative, such as the word and. Replace abbreviations. Now, stem words, that's where you reduce the words to a common format, and complete words are where you convert the stems to an easier to interpret word. And then we remove unformative frequent words, remove sparse words, and then we convert to another format. Now, something to think about when you do this is that every analytics project is going to have a different, optimal order for what to do, and you need to look at what you have to work with, look at your documents, and choose what works best. If you see a whole bunch of numbers throughout, and those numbers are not going to be useful for what you're doing, you want to remove numbers early on. One thing that I frequently do is I'll remove stop words first, and then I'll remove stop words later after I do some pre-processing to get things into common formats again. And that will speed up my processing. A good rule of thumb is if it removes more words, as we also call those tokens, if it removes more of them, then it's probably the one you want to do first, because that will help speed up your processing time. And you will get different results depending on the order in which you perform these tasks. So you have to really think about why you choose the order you choose. All right, so tonight, what I really want to do is I want to just talk about tools to use while doing text analytics, for string manipulation in particular. And I'm just going to show you, here are the tools in our tool belt. I'm not going to show you how to use them. That will be in the next video. Here, what I want to do with these PowerPoint slides, I want to set it up so that as you're working through a project, you're like, hey, what's the function that does this thing that I need to do? You can go and you can look that up. All right, so the format of strings really is important because different functions in R interact with different formats better or worse, or not at all, than others. And the most common ones are vectors, data field frames, and corpi. So and each function package has a preferred format to work with. In base R, it's vectors and data frames. In Stringer, it's the same as base R. And the TM package has these things they call corpus, and it really prefers to work with those. And what you have to do when you decide on how to manipulate your strings, you need to look up the format of the function. Like, you find the function you want, you make sure that it will work on the format that you have. You may need an additional function to help you, and then you execute it. And you always have to consider the format that you have it stored in and the action that you want to perform. If you want to use a non-corpus function on a corpus, you're going to need the TM map function from the TM package. My opinion is that the stringer functions are better than the base R counterparts. Now, something about that is I learned the base R ones first, and I just never kind of got away from that. I guess I'm old and I'm kind of set in my ways, but there's a lot of good reasons. The one that jumps to my mind first and foremost is that the base R functions handle NA, missing values, as the letters NA, which is a huge pain in the neck, but the stringer functions do not. All right, so now let's take a look at like the meat and potatoes functions for string manipulation. All right, there's a whole bunch here, and we're going to go through. So here, this column is for like the base R functions, and over here are for the stringer functions that do the corresponding things. So here, if I have paste 0 or paste or stringer C, these concatenate strings. So paste 0 does not by default have any space between the concatenation. Paste puts a space between the items being concatenated. And something to realize is that when I talk about the base R functions, frequently they convert NA to the string NA, which is kind of bad. It is bad. Now, number of characters in string length counts the number of characters in a string. One thing that's nice about the stringer package is that if you pass factors to it, it'll just accept them as character strings and it'll roll with it. The base R functions will not. So if you want to use base R, you have to make a conversion first using the as.characters function. Now, substrings, here we extract the substrings by the position. So we have to say where we want to start and we want to stop when we use these functions. So if I want the second and third letters from a string, I have to put 2 and 3 inside the function. Now here, the grepl, this is a logical. Get the detect whether a substring appears in a string, yes or no, true, false. Here it's called string detect. Now, string subset, what does it is string detect, and then returns the string that you're looking for. String extract pulls out the matching patterns from a string, and string count counts the number of times a pattern appears in the string. So one thing I've noticed in the politician tweets, dollar signs appear a lot. So something that might be interesting is to look at how many times do dollar signs appear in the different politician tweets. Now, we can also split strings. This is one I do frequently at work. So what we do, we identify a character string that that is like delimiting different parts of a string, and then we strip it out, and we separate them out. And the string split function gives you a list, and the format can kind of be a pain to work with, but it's consistent and it's good to work with. Now, sub and string replaces the first occurrence of a string pattern. Gsub and string replace all replaces all occurrence of a pattern. I use these a lot. Now, string view and string view all helps you. It'll launch an HTML file showing you specific aspects of the string that you are looking for, and they'll be highlighted. Very useful when you're trying to figure out what you should and should not do. Now, converting to uppercase. If you've been working with data for a while, you'll notice that a lot of places will put all caps in their column headers just to make things uniform and consistent. I think that's visually ugly, but you can do it. To lower converts all the letters to lowercase. When we're doing like cinema analysis, when we're doing Bagofwords, and we're doing other types of analysis, we usually want to have everything in lowercase. Or lowercase is the more common one to be done. We want everything in the same format, because the system, if I've got like all uppercase, all lowercase, and first letter is upper, everything else is lower, then R will think that these are different character strings, and putting them all in lowercase or uppercase, if you really want to, it makes things more uniform, makes things work out better. Now, we can also convert our strings to proper title cases. I like to do this for my column headers. I like to have it in title case, and we can convert strings to sentence capitalization, which is nice. And then there's format C for formatting numbers. This is good for standardizing numbers in different formats, like if I've got commas in there in some of them, but I don't want those commas in there. Right lines is good for printing text, and charter translates specific characters to another character. I haven't used this one very much. Another package that you can use is the StringI package. There's kind of a strong following on the internet over this one. It works pretty good. I personally haven't found it to be advantageous over Stringer. All right, now let's get into some weeds of this. So, some other things that we're going to want to do is, when I'm going through, I want to remove punctuation almost always for the type of analysis I'm doing. We might want to remove numbers, and now we want to remove redundant white space. So if I have, let's say that for some reason somebody put 3 spaces between 2 words. Well, I only need 1 in there. The strip white space function will reduce like 3 spaces down to 1, and also get rid of leading and trailing white spaces. So this way, it'll be a little bit easier to read. My strings will be shorter in length, and things will process faster. The QDAP package has a lot of really neat functionality to it. Now, I had issues with Java with this, and R again. We've talked about this issue in class before, so this may or may not work on your machine, but the bracket X function will remove text contained within brackets. We can replace numbers with their word equivalents. We can replace abbreviations. This one's really nice. We can replace contractions, one I like a lot. We can replace symbols with their equivalent, so we can replace $signs with the word dollar. And it has a utility. Now, QTAP regular expressions has a whole suite of functions for removing special types of substrings. So we can remove URLs, we can remove Twitter URLs. There's a whole bunch of these. There are a whole bunch of special remove substring functions in the QTAP regular expressions package. I really suggest that you check it out. Now, R is going to have different formats for the data to be stored in, and so if I want to take a vector sort, if I want to take some strings that are stored as a vector and then I want to convert it to a corpus, then I want to use the vector source function. If I have a data frame source and I want to convert that to a corpus, then I want to use the data frame source function. And vcorpus function is very similar to vector source. So I take vector source and I put it into vcorpus. And now NLP has some other features for us to be able to dig into to extract features from documents where I've got like metadata. We're really not going to use it in this class. Stop words. Stop words are words that are not informative for our analysis. Now, something I want to point out is informative for our analysis. So the default examples are words such as for, and, nor, but, or, yet, so. These words are grammatically important. These tell us what the words are doing in the sentence. But if I see these, if I was to see these words, just kind of displayed out, and I wouldn't know what was going on. Now, if I saw, let's say, dock, river, water, boats, I have an idea that like all those words together tell me something about what's going on in the document. Those are informative words for what's going on. Now, it depends on our situation. So let's say I am going through and I'm doing text analytics on pediatric medical journals. Well, in that situation, pediatric children are not going to be informative words because they're going to appear everywhere throughout those documents. But if I was analyzing a bunch of cardiac medical journals and I see pediatric children, then I know that those are special topics within cardiology. So in the situation of pediatric journals, I would want to remove the word pediatric throughout because that doesn't really tell me what's going on for the context of what I'm doing. So the TM package has a function called stop words that returns a vector of words that are generally not informative in English. So there's two major options to go through, either SMART or English. If you use the English one, there's 174 common words that are stop words. The SMART one has 571. The CubeDAP dictionaries package also has some good stop words. So the top 25 words, top 100 words, and the top 200 words. These are the most, what the dictionary says are the 25 most common words in the English language. Most common 100 words and most common 200 words. And so these are, they're so frequent that they're not useful for our analysis. And what we want to do, we use these dictionaries and the TM remove words function to remove these words from our text document. Removing stop words will greatly improve the speed of our analysis, and it will improve the output also. So you definitely want to remove stop words. Stem and complete. Stemming words is where we convert words to their common stem. All right, so let's say that we're interested in, we see the words complicated, complication, and complicatedly. Well, these all have a common stem of complic. All right, now, what we're going to do, we're going to convert all of these to their common stem of complic because these are all referring to the same thing of like being complicated. Well, after I do that, if I read complic, I don't know what complic means. That's not, in my normal vernacular. All right, so what we're going to do, we're going to complete the stems into a common format. So what we're going to do, we're going to convert the word complic to complicate. So all of these words, these three, when I'm done, will be converted to complicate. First, I stem them to a shorter common version, and then I complete them to a common version. Stemming is usually pretty quick, but completion can take a long time. I honestly recommend, if you don't have to show anyone your output, just not doing the completion phase of your analysis. It just takes too long. It's not really, it's not that helpful if we're going to be doing things like Bagofwords. What you could do is go through, run your analysis without completion and see what is important, what the important words are, then go back and complete only the important words and rerun your analysis that way. I think that's a better way to go, because you can waste a lot of time trying to complete your stemmed words. All right, so stem document is the function to reduce your words to stem. It's in the TM package, and stem completion completes them. And you have to tell stem completion what how you want to identify which one to go with. Either you can go with the most frequent terms in your collection of documents, or you can go with the first, or you can go with the last, or you could go random. It's up to you. The most common one is probably the best one to use in most situations, but that will also take the longest to complete. Like we said earlier, the TM map function is how we apply a function to a corpora. And we use a content transformer also for that purpose. Bagofwords. So the idea of Bagofwords is that I'm going to convert my documents into a matrix. What I'm going to do, each document is going to have a row or column, and then each token, or that's word, is going to have a column or a row. So, and the entries will indicate either the presence of a word or the number of times the word appears. All right, so now why do we want to do this? Well, if I want to be doing statistics, if I want to do machine learning, I have to somehow, some way, some shape, some form convert what I have into numbers. And this is the benchmark way of converting documents and tokens, words, into numbers. Right, so we can either have a document term matrix. If I have a document term matrix, then documents refer to or correspond to rows, words correspond to columns. If I have term documents matrix, then each term corresponds to a row, each document corresponds to a column. Most of the time we're going to be using document term matrix. There's a few functions that want term document, but once you have one, they're quick to switch back and forth between the two formats. So for count matrices, the entries are the number of times a word appears in a document, and that might be 0. For binary matrices, a 1 indicates that the word appears 1 or more times in the document. 0 indicates that the word does not appear in the document. Now, something to keep in mind is that since these are count matrices, these are non-negative matrices, and we're probably going to have a lot of zeros. If I'm doing, if I have a large number of documents I'm analyzing, I'm probably going to have a lot of zeros on there. They're going to be sparse matrices. All right, so when I have a sparse matrix, so if I have some words that only appear, let's say, in like 1% of my documents, those really aren't helpful. Think about it as, when we talk about like convergence in our stat theory class, if I don't have enough observations, I can't have convergence on my sample means and stuff like that. Well, if I'm in that type of situation with a word where it doesn't appear frequently enough to be useful, then I really shouldn't include it. In that case, I really want to get rid of it. This is basically an extension of variable selection. So what we want to do, we want to use the remove sparse terms function from the TM package and get rid of things. And now, how sparse is too sparse? That's up to you. You might choose 0.9, you might choose 0.95, 0.99. It's up to you. You'll have to just kind of make a judgment call. If the stricter you get, the fewer columns you'll have to work with. That might be good, that might be bad. You have to make a decision on your own. Now, after we get through and we've built our text, our document term matrix, and everything's looking good and we're feeling good, we want to take a look at what's going on. And so we're going to want to do some visualizations. So word clouds are by far the most well-known text analytics visualization out there. they are readily accepted by audiences. People feel like these are very, very informative. I feel like they're not as informative as people like perceive them, but they're really good. They're a good place to start. You can look at the word cloud and know what the overall topic of a document is. So something that I know teachers have done is that they've taken like famous speeches and they've given their students just the word clouds of the speeches, and they've asked the students to tell them, all right, what's going on in the speech? What's the topic of the speech for the analysis? And the students were very successful at that. A lot of Martin Luther King's speeches were presented by this particular teacher this way, and it was a good way for her to start this part of the semester. Commonality cloud is like usually what you want to do here. This is when you have two documents that you want to compare, or maybe you have like two different authors and you want to compare and contrast how they are similar. Pyramid plots are good for comparing, contrasting two different authors or two different documents. And the QDAP word associate function creates a graph showing which terms are associated to each other. You really need to only work with a few words or a few documents if you want to use this. It gets just to be overwhelming really quickly. All right, so that's all I've got for us. Next time we'll start looking at some more aspects of string manipulation. We'll get into specific regular expressions to help us speed up what we're doing to grab onto stuff and to make it smoother and easier for us. And then after that, we'll start actually doing examples and get into the meat and potatoes. Well, thank you so much, and take care.